to the first video of the series around the Automatiko project. Today we are going to have a bit of an introduction to see what it is, what it can be used for, and how to get started. So first of all, if you want to get a bit of an information about what the Automatiko project is, just go directly to the Automatiko.io website and you will get a bit of information, what it is, what it can be used for, some of the various use cases. You can run examples, and here you find as well one of the most important parts is how to get in touch with us. So we have the Twitter account, we have the mailing list, and the GitHub project itself. If you want to get a bit of information about what it is and what kind of concept it has and so on and so forth, take a look at the documentation docs.automatiko.io. And today we'll start with a simple project that is for the IoT use case. So let's head directly to our IDE. We use Eclipse because we have the Eclipse plugin to get the setup of how to work with it. You can get getting started. So you have all the required tooling, how to get to install it, and so on and so forth. So this will get you started. Here we have how to create a project as well. Today we're going to use the IoT archetype. So we'll interact with MQTT server. So without further ado, let's get started. So we create a Maven project. We directly go here. We look at the Automatiko archetypes. And we find our IoT archetype. 0.2.0 is the currently latest version available. So let's get started with that. We use the ORACME as the group ID, IoT sample as the artifact ID. And that's pretty much it. So we get this going. So it's going to import the project directly. So we have the standard Maven structure. So what we want to start with is that we start with our simple data model. So we wanted to capture temperature information from the sensors. So we create a class temperature. And it will have two fields. Oh, just a small typo with the double E here. Right, it started to index everything all of a sudden, and then we create two fields. One will be of the type double, it will be value. Another will be of type string called room. So this is the place or the location where we get the sensor data from. So we simply create the getters and setters for that. And that's pretty much it. So that's our simple data model. Then we look at creating our workflow definition. So we go here into other, and we simply look for the Automatiko process diagram. This requires obviously to get the plugin installed, as I showed you on the documentation website. So we start with that IoT sample, IoT process ID. We can leave the sample, and that is pretty much all we need. Alright, so with the concepts of Automatiko, first and foremost we want to document. So sample IoT workflow that reads data from temp sensor. That is to simply document our service as well. Oh, sorry, it's in the wrong place. It should be actually here on the process level. Then we have our start event, but we want to capture data from our sensor. So we create the so-called data object. We give it a name. We can give it a type as well. So we look for data type. So we add just data type. And that's our data model we just created. That's pretty much it. So we have our data model. Then what we want to have here, we want to map it with a message event definition, and the message event definition allows us to connect to a particular message broker. In our case, for IoT, it's MQTT. So we create a simple message, and then we say it is of a data type temperature. So everything that comes from the topic called temperature will be mapped directly to the temperature data type. And then we want to assign that to our data object called temp. So we have already linked with the data, so we can then create a simple user task just to get the information out of it. Just actually render it here, and then we finish the process and event. So we look at the objects. We start with the input mapping. So we want to have the temperature assigned to us. We want to name it current value, and it automatically sets the type. So we have it here. Here we can control on what is the name of the task that will be visible in our service API. We can as well exclude users, groups, or assign actors to it, but we are not going to do that today. And then we simply show latest value. Right, and again we have it linked there. So we can simply save it. We don't want to configure validation of it. So we have the model, we have the data model, we have the process, we have the message bound with the both data object and user task to display the data. So now let's look into how we can get started with MQTT. So for MQTT we'll use the Eclipse Mosquito project, and we simply run it as a Docker. So we just start that, we get it up and running. So here we go to IoT sample. This is our Maven project. So we can simply run and clean. And we start in the dev mode. This is a Quarkus project, so it will give us immediate feedback. We get this started in a few seconds, then we can start looking at them. Alright, so it got started. We can simply go and look at the localhost and then Swagger UI. So as you can see, this is our service API created out of the box based on the data model created with all the endpoints. As you can see, the user task, we have the our documentation. They are directly taken from the workflow definition as well. So we can look at what we have here. No workflow data at the moment. So to get it started, as you can see, we don't have anything else. So we simply get the Mosquito publishing. So we have the topic temperature, and this is our data. So we give the living room value 10. That's it. And then if we go back to we already have this value connected. So it already takes the information out of the MQTT broker, displays it here. This is auto-generated ID of the workflow instance, but this is not the only thing that we can use. We can leverage the concept of a business key that will allow us to get this more closer to the domain we are dealing with, meaning the fetching or capturing temperature of different rooms. So let's modify our process, our workflow, to take advantage of data that we have inside the message that we receive. So we go into the message that we defined for connecting to MQTT, and we simply create a new custom attribute which is called correlation expression, and we give it the value of event data get room. So this is event data. So this is actually mapping to the incoming object that is already transformed into our own data type, so we can use that as part of our workflow instance creation. So we do that, we save it here, we don't configure the project again, and then if you look back, we still have this single instance. Just it went down. Let's see what we have. All right, it refreshed everything, great. And then if we send another message here, let's give it 25, and let's go back to our project here. And as you can see, the ID is taken directly from the message payload. This is not the only way of fetching the information about it, but one of the most commonly used. Another approach could be that whenever we use a wildcard topic, we can then extract the particular element of the topic to grab the correlation as well. This shows us how quickly we want to get this running. So this was running in dev mode, so you could see that it was constantly checking on the changed resources, meaning our workload definitions files, and was directly refreshing it without us being required to restart anything on the service. But we can as well want to deploy that in not just our local environment. So what we could do is we simply could create a package, and that would be an executable jar file, or we could go directly to a container. So if we run the build with the profile container, it will create directly for us a fully runnable container image, so we can then display it. And as you can see, automatically gives you a bunch of instructions as well upon the build time, so you can have a bunch of information how we could actually use that for your Docker images. And then we simply scroll up and we will find our sample already built and ready to run. Alright, this concludes the first introduction to Automatiko and IoT use case that can be built with Automatiko. Thank you for listening, and have a look at the comments, website, and share your feedback.